Hey, here's some more examples of solving by substitution. Okay, so step one is to isolate x or y. So it looks like we already isolated for either equation. We're already isolated, so we can go ahead and move on to number two. Okay, says substitute into other equations. So I am going to take x plus 5 and substitute that into the y for the second equation. So both of these calculations are y. So I get, so for part 2, I get x plus 5 is equal to 2x minus 7. Okay. Step 3 is to solve for the next equation, or for the x or y. In this case, it's going to be x. Okay. So I'm going to go ahead and subtract x from both sides, giving me 5 is equal to, 5 is going to be 2 minus 1x, gives me 1x minus 7. And then I'm going to add 7 to both sides. That makes a 0. So I get x is equal to 12. And I'm going to hold on to this for step number 4. Step number 4 is solve for the second variable. Okay. So, to choose either equation. It looks like the top equation is a little less complicated, so I'm going to use that one. Y is equal to x plus 5, and we know from step 3 that x is equal to 12. So y is equal to 12 plus 5, so y is equal to 17. Let's see. And then we're going to write our solution as an ordered pair for step 5. Okay, so the solution is x comma y, which we can replace with 12 comma 17. Okay. Step number 6 is to check your work by graphing or solving algebraically. I'm going to go ahead and solve algebraically. So step number 6 is to check, and I need the equation. So first equation is y is equal to x plus 5, and the second is y is equal to 2x minus 7. And I am checking the ordered pair 12 comma 17. All right, so x is 12, y is 17. So I get y is equal to 12 plus 5. So 17 is equal to 17. Check. Okay, so next one, y is equal to 17. 2 times x is 12 minus 7. So 17 is equal to 24 minus 7, and 24 minus 7 is 17. What if you got something like 16 is equal to 12? Okay, if this happens, then your ordered pair that you tested is not the solution. Okay, but lucky for us, it looks like 17, that our two equations worked out, and so we know that 12 comma 17 is the solution to our system. All right, next one up. So step 1 is to isolate x or y in one of the equations, and it looks like they are both isolated. Okay, so the second step is to substitute one equation into the other. So I'm going to take negative 4x plus 3 is equal to y. So I'm going to go ahead and plug that into the y into the second equation. So I get negative 4x plus 3 is equal to negative 4x plus 3. Go ahead and solve. I'm going to add 4x, giving me 0. And then I'm also going to subtract 3, giving me 0. So I get something like 0 is equal to 0. No variables left. And the statement is true or false. is true, so therefore this is infinite solutions. Let's try that again. Which, if you remember, means that the line is exactly the same. Look at these two equations. Aren't the lines exactly the same? Yes, infinite solutions. Okay, last one that we're trying. I'm going to find it here. Okay, so x is equal to negative 3y minus 3, and x is equal to negative y plus 3. So this time we're going to isolate x or y in one of the equations, and I see that x is isolated in the top equation. X is also isolated in the bottom equation, so we can move on to step 2. So I have a calculation for x. It is negative 3y minus 3. And I'm going to substitute it into the x in the second equation, or the other equation. So I get negative 3y minus 3 is equal to, I'm going to write everything on the right side here, negative 3 plus 3. So the x from the second equation is being replaced with the statement from the first equation. Okay, so you can isolate x, is what I'm trying to say here. It's okay to isolate x and solve for y first. All right, so I'm going to add y to both sides. I get negative 2y minus 3 is equal to positive 3. I will go ahead and add 3 to both sides because of inverse operations. 6, so negative 2y is equal to 6. We'll divide by negative 2. So y is equal to negative 3. So I will hold that for later. Now that I know what the y value is, it's time to find my x value. So step number, I think it's 4. Solve for the second variable is step number 4. Okay, so solve for the second variable. So much scrolling. Okay. Step 4. All right, you get to choose which equation you would like to use. I'm going to go ahead and go with the second one this time. Negative y plus 3. And x is equal to, x is what I'm trying to figure out, so I'm going to leave the x. The negative sign is from the equation. I'm plugging in the value negative 3, and for y, okay, plus 3, notice the double negative. So negative 3 times 3, negative 3 is positive 3, plus 3 gives me x is equal to 6. Okay, step 5 is our solution, or what we think is the solution. So remember, we're doing x comma y, so I'm going to have 6 for my x and negative 3 for my y. Just because you solve for y first doesn't mean it goes first in the ordered pair. All right, lastly, we got to check. We're going to check, and our two equations are x is equal to negative 3y minus 3, and x is equal to negative y plus 3. What are we substituting? We're substituting 6 for x and negative 3 for y. Okay, so 6 is equal to negative 3 times negative 3 minus 3. That's a lot of 3's. So negative 3 times negative 3 gives me 9 minus 3, so I get 6 is equal to 6. Verified. Okay, next equation, 6 is equal to negative 3 plus 3, so 6 is equal to positive 3 plus 3, which is 6 is equal to 6. Verified. So our solution is the ordered pair of 6, negative 3, meaning the two lines cross at 6, negative 3.